So for victim retrieval in the Erebus competition, there are two ways to perform victim retrieval. You can do it with trigonometry or without trigonometry. Now the without trigonometry version is a little more elegant. So in this video we're going to basically teach you the basics of trigonometry so that you can use it for the Erebus competition. Remember that it's not completely necessary and that in our main tutorial, Victor shows you a way to perform victim retrieval without using trigonometry. But if you're interested on how trigonometry works, this video is for you. So over here, I have this triangle. It's a right triangle with angle theta right over here. It has sides A, B, and C. Over here, I have a similar triangle in that it also has a 90-degree angle and also has an angle theta over here. However, it has sides A prime, B prime, and C prime, which are shorter than their counterparts from this triangle. By AAA similarity, however, I can conclude that these two triangles are similar. This is because these two angles match up, these two angles match up, and these last two angles match up. This is because for any triangle, the angles within have to add up to 180 degrees. So for this triangle, theta plus 90 degrees plus this last angle must equal 180, as shown by this equation. In this triangle, theta plus 90 degrees plus this last angle also has to equal 180 degrees, which is the exact same equation. So theta plus 90 are both the same in both triangles because these two angles are the same in both triangles. Therefore, this last angle in both triangles right over here has to be the same, so this equation holds true for both triangles. So now that we determined that these two triangles are similar because AAA similarity, because all three angles line up with each other, we now know that the ratio between A and A prime is the same as the ratio between B and B prime, which is the same as the ratio between C and C prime. So we can set up this equation right over here. We can then rearrange the terms to set up three more equations, as shown right here. What these equations show is that between these two triangles, the ratio between two sides always stays the same. Let me explain what I mean. In here, I have an angle theta and a right angle. And when I take this side B and divide by this side C, I will get a value. And I'm going to remember that value. Take this triangle over here now. It also has the same angle theta and the same right angle. This is what makes these two triangles similar. If I take this B side, this B prime side, and divide it by this C prime side, it will be the same value as B over here divided by C over here. This is proven by this equation right here, which we showed through AAA similarity. So that means it doesn't matter how large this triangle is. It could either be large or small. If it has a 90-degree angle and this angle theta stays the same between both triangles, if I take any side and divide by any other side, the ratio will hold between triangles. So if I take B divided by C, B divided by C over here will hold the same value as shown by this equation. Then if I take A divided by C, it would be the same thing as A prime divided by C prime shown by this equation. And this works for all permutations of the triangle as long as you maintain that theta is the same in both triangles and they are both right triangles. So now we've established that for any right triangle, if I keep this angle theta constant, the ratio between two sides will always be the same. So we can use this and we define the three basic functions of trigonometry. They are sine, cosine, and tangent. Now for a little terminology. The opposite leg is the leg that is opposite the angle. For this triangle, you can see that side C and side A both touch this angle theta. Therefore, B would be the opposite leg in this situation. The adjacent leg is the leg that is touching the angle. In this case, it would be A. Now, it couldn't be C because C is the hypotenuse, and it's the hypotenuse because it is the side that is opposite the 90-degree angle. So for this particular triangle, for this angle theta, B is the opposite leg, A is the adjacent leg, and C is the hypotenuse. Now, sine theta is defined as the opposite leg divided by the hypotenuse. In this case, it would be B divided by C. Now, sine is a function. What that means is I can take an angle, theta, and input it into the sine function, and it will give me back a value. Let me show you what I mean. So, I can take the sine of an angle. Let's say it's 30 degrees. So what this means is for my right triangle, this angle right here, this angle theta, is 30 degrees. So if I take the sine of 30 degrees, I will get 0.5. What that means is if I take B divided by C, for any right triangle with this angle theta 30 degrees, B divided by C will always yield the value 0.5. Cosine works in a similar way, except it's defined as the adjacent leg over the hypotenuse. In this case, that would be A divided by C. So if I take the cosine of 30 degrees, I get 0.866 approximately. What this means is if I take the adjacent leg divided by the hypotenuse of this particular triangle with an angle 30 degrees right here, A divided by C will always come out to be approximately 0.866. Tangent works similarly, except it's the opposite leg, B, divided by the adjacent leg, A. So that means if my angle is 30 degrees and it's a right triangle, B divided by A will always yield, tangent. So B divided by A will always yield 0.577. So one thing to note is that sine of theta, cosine of theta, and tangent of theta are defined as these expressions right over here, not these. These expressions are for this triangle specifically, but these apply to all triangles. So let's say I move my angle theta to this angle right here. So now this angle right here is theta. Sine theta is still defined as the opposite leg divided by the hypotenuse. So sine theta will be defined as the opposite side, A, divided by the hypotenuse, C, because A is now the opposite leg to this angle theta right here. So sine theta is no longer defined as B divided by C. If theta was up here, it would be A divided by C. And both cosine and tangent change accordingly too. So, in other words, the definition of the trigonometric functions are this equation right here. These equations right here are only for this triangle specifically. So make sure you be careful of that. So now we have our three basic trigonometric functions, sine, cosine, and tangent. Now, let's say I wanted to solve this equation for theta. I need a way of undoing the sine so I can solve for theta. Now, if I have multiplication, then I can always undo it using division. If I have addition, I can always undo it using subtraction. When it comes to the trigonometric functions, each function has their own inverse function that I can undo the starting function. For example, sine theta has an inverse function of arcsine. So when I take the arcsine of a sine, the arcsine cancels out with the sine. So I'm going to take the arcsine of both sides of this equation. Remember, if I apply the same operation or function to both sides, the equation holds true. So I'm going to take the arcsine of both sides. So arcsine of sine of theta. And the arcsine will cancel out the sine, leaving us with just the theta right here. Then I'm going to have the arcsine of B over C, as you see right here. Now, there's also arccosine and arctangent, and they do the same thing as arcsine, except for their own respective trigonometric function. So we actually use two different units to measure angles. Just like with lengths, we can use inches or centimeters. For angles, we can use degrees or radians. You're probably more familiar with degrees. But the reason why you need to account for radians is whenever you code using trigonometric functions, the libraries almost always use radians. So for sine, if I use the sine function provided by math.h for C++ or math for Python, it actually intakes an angle inside of radians. So my theta has to be in radians when I code it. Alternatively, if I use arcsine, the asine function, this returns an angle in radians. So the conversion between radians and degrees is actually pretty simple. I just take my radians, multiply by 180 and divide it by pi, and I'll get degrees. So for this angle returns in radians. I just take what this returns, shove in here, multiply by 180 and divide by pi. Then I get my angle in degrees. Alternatively, I can solve for radians by multiplying both sides by pi over 180. So if I have my angle in degrees, let's say this is 30 degrees, I just put 30 degrees in here, I multiply by pi, and then I divide by 180. Then I take that, that's my angle in radians, I shove it into the sine function, and then it returns a proper ratio. And do note that whenever you use b over c, so the output of sine and the input of arcsine, you don't need to worry about radians or degrees because these are simply ratios between the lengths. So if you didn't understand everything that I talked about on this slide, don't worry about it. This is just kind of a proof of concept of the basic trigonometry. So if you didn't completely understand everything that I was talking about in this slide, don't worry about it. It was more of a proof of concept of the basic functions of trigonometry. I'm going to do some examples which you should listen to, and that should give you a better feel how to use trig for this particular challenge. So for our first example, we have this triangle over here. It has an angle of 30 degrees right here, a leg of 5, and then this is the side that we want to figure out the length of. And we have our basic trigonometric equations right over here. So now, to solve this problem, first off, we're going to have to figure out which equation we want to use. And we use that by figuring out what legs we have, or what sides we have. So I have my angle right over here. I know that this is my hypotenuse because it's opposite the 90-degree angle. So we know that I don't have my hypotenuse. Now, two of these equations have the hypotenuse. So that means since I'm not dealing with the hypotenuse, I'm not going to use either of those equations. So I'm not going to use sine, I'm not going to use cosine because they both involve the hypotenuse. So I'm just going to use tangent. So my first step is going to be substituting my values into the variables right over here. So now tangent, the tangent of my angle right here is going to be the opposite leg x divided by the adjacent leg 5. So tangent of 30 degrees equals x over 5. Now I'm going to be working in degrees. You have to make sure that when you code it out, you have to convert your angles to radians because for when you code, these functions take in radians. So I would have to take 30 degrees and shove it into this equation right here. So I'd do 30 degrees times pi divided by 180, and that would be my angle in radians, and this is what I would shove into my tangent function. From there, we can isolate x by multiplying both sides by 5. And then from there, we can just evaluate this because the computer will do the calculations for you if you include math.h for those of you using C++. And if you import math for those using Python, that should also give you the trigonometric functions. And this results into 2.887 approximately. So I know for this particular triangle, x is equal to 2.887. So this is example 1. Now for our second example, we have this triangle over here, and instead of having an unknown side, we have an unknown angle with 2 sides. But the process still is pretty much the same. First things first is we have to figure out which one of these 3 equations we want to use. Now, as you can see, I have the hypotenuse and I have the opposite leg. Remember, this is the opposite leg because it is the leg that is not touching the angle. We don't have the adjacent leg, which is the leg that is touching the angle. So I can see that cosine has an adjacent leg and tangent also has an adjacent leg. So I'm going to be using sine. Now I'm going to substitute my values into this equation. So I'm going to have the sine of theta equals the opposite leg, 5, over the hypotenuse, 10. To isolate theta, because I want to solve for the angle, I take the arcsine of both sides, and I get theta, because arcsine of sine cancels out, leaving with just theta, equals the arcsine of this right side, the arcsine of 5 over 10, or 1/2. Then I just let the computer do the arcsine for me, and it comes out to 30 degrees. So I now know that this angle is 30 degrees. You have to remember, once again, that arcsine returns in degrees. Remember, you don't have to worry about these values because these are simply lengths, not angles. But arcsine returns an angle, so what arcsine returns, you're going to have to feed into this equation right over here, because arcsine returns in radians, so I shove in the radians right here, multiply by 180 and divided by pi, and I get degrees out of it, so my angle is going to be 30 degrees. That is example 2. So now you should know enough trigonometry to perform a more elegant version of victim retrieval. And now that you have your foundations down, make sure to go watch the rest of our main tutorial. Thanks for watching.